During your virtual days, you should have completed the Desmos activity called Function Carnival. In this first slide, you watched a video of a man being shot from a cannon and relating the time after he was shot from the cannon to his height off of the ground. On the next slide, you added a label to show you all of the coordinate points that show this relationship. So the first point shows the time that he's been in the air, and the second point represents his height from the ground. This point specifically, 5, 12.3, tells us that at 5 seconds, Cannon Man was 12.3 feet from the ground. And notice there was this slight change in the rate of his descent. He was going quite quickly and then he slowed, so this must have been the point when his parachute opened. This point at the very top here would represent at 2.8 seconds. Cannon Man was at his maximum height of 32.114 feet. So right before this point, he was still flying into the air, and then right after this point, he changes directions and starts to descend back towards the ground. These three statements all discuss a relationship between the time Cannon Man was in the air and how many feet he was above the ground. Notice they are all three statements, but in math, we can use something called function notation to present the exact same information. So this first statement, we would read it as f of 2.8 equals 32.144. And that literally means that after 2.8 seconds, Cannon Man is 32 feet above the ground. Here, f of 5 equals 12.3 literally means after 5 seconds, Cannon Man is 12.3 feet above the ground. So function notation is a way of relating the function's input to the function's output. By stating after 8 seconds he was 4.92 feet off the ground, this would mean that at f of 8, so at an input of 8, the output was 4.92. The card should have been sorted as so, and recognizing that what you see in function notation, so our input represents the x value of the point, and the output of 8 represents the y value of the point. And this is true for every single one of them. So you can pause and read through them to make sure that they match up. We can consider the advantages of function notation. In terms of advantages of words, we can clearly communicate what we are trying to say. In this case, after 7.5 seconds, Cannon Man was 6.15 feet off the ground. However, function notation is an easy way to abbreviate this same statement and allows us to easily compare two or more statements. In the video of the Ferris wheel, this function notation is saying the input of 5, aka 5 seconds, what is the output? So if we go to the point that has an input of 5, we can see that A must equal 8. So at 5 seconds, the height of the Ferris wheel is at 8 feet. In this case, it's actually asking us the opposite. It's giving us the output and asking us for the input. So it tells us that the height of the Ferris wheel is at 12 feet. So how many seconds have gone by for it to be at that height? Well, in this case, there's actually more than one point. So notice at 2.5 seconds, the Ferris wheel is at 12 feet, but then also at 12.5 seconds. So in this case, we might say A equals 2.5 or 12.5. At this point, you can head over to your notes so we can talk a little bit more formally about what function notation is. So to put it simply, function notation is another way to write an equation that is a function. In this example, the equation y equals 3x minus 4 can be written using function notation. So all we're doing to start is replacing y with f of x. So in this case, the f does not represent a variable. It actually represents what we are naming the function. So in this case, our function's name is function f. I can really use any letter to name my function itself. So f of x equals 3x minus 4. As we said before, x always represents the input, and then we use the expression 3x minus 4 to determine the output. Going over here, given the point 3 comma 5 using function f. So we're still using f of x equals 3x minus 4. So we're told that the input is 3, and then the output is 5. And we can double check that because f of 3 should equal 3 times 3 minus 4. Again, I'm using the rule over here, the expression, to help me determine my output. And 3 times 3 minus 4 does simplify to an output of 5. In the next example, we're going to call our function function g. So I state that g of x equals 2x minus 5. If I'm asked to find g of 4, this really means find the output when the input is 4. So looking at this in terms of a table, it might look like where 4 represents my input, and then I use the expression 2x minus 5 to figure out my output, but I'm replacing x with 4. 2 times 4 is 8, minus 5 is 3. Therefore, I would state that g of 4 equals 3. So once again, in this case, you are given the input, but then you have to find the output. Notice in this second example, it's asking us to find x, aka find the input given the output. So again, this time we are given the output, and we have to find the input. So in terms of a table, it's going to look a little backwards. And instead of the input this time, we are given the output. So 25 would go here. So in this case, instead of replacing x, we're actually solving for x by setting 25 equal to the expression 2x minus 5. I'm going to go ahead and solve that. So x equals 15. So an input of 15 gives us an output of 25. Going back to the Desmos function of the Cannon Man relating his height to his time to his height in the air, at 5 seconds, Cannon Man was 12.3 feet above the ground. So that represents this point right here. So that's 5, 12.3. But in function notation, at this point we know we'd say f of 5 equals 12.3. So I can also fill out function notation using the graph. So this says when x is 10, so I have to go on the x-axis. So this is the point where x is 10, and the output in this case is 0. So f of 10 equals 0. Lastly, now I'm given an output of 0, and it asks me for the input. So notice that this point has an output of 0, and this point also has an output of 0. And then all of these points have an output of 0 too. So we actually have quite a few potential inputs that give us an output of 0. So we might say x equals 0, 10, and we could even include 12 in here. Lastly, we can demonstrate using function notation from a table. So the ordered pair given in the first row of the table can be written using function notation. So I'm talking about the coordinate pair, -6, 8. So -6 is our input. So we'd say f of -6 equals 8. To determine f of 3, since 3 represents our input, or our x value, I look at this column, and I find an input of 3, and I see that it gives us an output of -2. So f of 3 equals -2. And for the last one, this time, -5 is my output. So this is f of x itself. So I look in this column where there's an output of -5, and it corresponds to an input or x value of 4. At this point, you will have to go back to Canvas or YouTube to watch part 2 of these notes.